person automation. I'm Amjad Mughal and I'll be your presenter for today's session. Thank you for taking time to join us. Whether you are a MuleSoft developer or a technology leader exploring how AI can improve delivery and quality, I'm confident that you'll find this session valuable. Over the next 1 hour, we'll explore how Falcon AI, part of Integral Zone's Falcon Suite, is transforming the way organizations design, build, and govern MuleSoft APIs. Here is what we'll cover. The common challenges MuleSoft teams face today, why traditional AI tools such as ChatGPT and Copilot often fall short in enterprise integration scenarios, how Falcon AI bridges the gap by bringing intelligent automation and governance awareness to MuleSoft, a real-world demo using Falcon AI with the help of simple bookstore API use case, and finally, we'll cover best practices, Q&A, and next steps. This session is being recorded, and we'll share the slides, demo links, and replay them afterwards. Please post your questions anytime in the chat. I'll pick them up during the Q&A near the end. Let's start by talking about current state of AI-assisted development and the limitations teams face when using the traditional LLMs. Before we get into Falcon AI, let's look at the AI tools many of us already use. Large language models, or LLMs, things like ChatGPT, GitHub Copilot, or Gemini. These tools are great for general programming, but when it comes to enterprise integration, especially MuleSoft projects, they face some serious limitations. First, they lack domain understanding. Traditional LLMs don't deeply understand Mule4 flows, data weave syntax, connectors, or endpoint platform configurations. So, while the code they produce might look right, it often doesn't compile or follow MuleSoft best practices. Second, they operate without governance context. They can't enforce your organization standards, naming conventions, logging patterns, error handling frameworks, or security policies. That means the generated code still needs manual correction before it can pass internal reviews. Third, they offer no awareness of your Exchange assets or enterprise environment. They cannot connect to your YAML specifications, your system APIs, or your development structure. So what they generate is isolated, not production ready. And finally, there is the security challenge. Generic AI tools don't validate the security use of credentials, policies, or encrypted properties. They can introduce vulnerabilities, misconfigured endpoints, or missing client ID enforcement without even realizing it. All of this means that while traditional LLMs are helpful for brainstorming or small code snippets, they are not enough for governed, secure, enterprise-grade MuleSoft delivery. What teams need is an AI platform built specifically for MuleSoft, one that understands flows, applies governance automatically, and enforces security best practices by design. And that's exactly what Falcon Suite does, which we'll explore in the next section. Now, let's talk about how Falcon AI fits into broader vision of AI that Salesforce has been championing. Salesforce's AI vision centers on combining generalist intelligence, which understands context and business intent, with specialist AI agents that can execute specific tasks intelligently, securely, and at scale. At Integral Zone, we align perfectly with that vision. Falcon AI brings it to life within the MuleSoft ecosystem by acting as the generalist intelligence that orchestrates multiple specialist agents across the entire API lifecycle, from design to deployment. This diagram illustrates how it works. The requirements and design phases are still led by senior architects. They define the architecture, governance, and business logic. Once the design blueprint is ready, the architect's main role is to craft the right prompts, a clear instruction that describes what needs to be built. From there, Falcon AI's agents take over. During development, Falcon AI doesn't just create scaffolds, it generates complete production-ready MuleSoft applications with flows, connectors, data wave transformations, and all aligned with organization standards. Governance and security are built at the time of code generation itself, not after. The AI automatically applies folder structures, naming conventions, error handling, proper encryption, and policy enforcement. Falcon AI then goes a step further. It checks that code is properly generated and checked into your preferred repository, such as GitHub or Bitbucket, and promotes the APIs to the Anypoint Exchange with full documentation and metadata. Its agents then handle the next stages: the code review, validating the compliance and applying fixes, testing, generating unit test templates and verifying configuration, deployment, enforcing encryption, packaging and policy consistency, and monitoring, tracking performance, governance, and quality trends in real time. So, the architect defines the intent through the prompt, and Falcon AI, powered by its network of intelligent agents, delivers everything else. The outcome is faster delivery, consistent quality, and built-in governance, moving from blueprint to exchange-ready APIs in hours instead of weeks. In short, Falcon AI brings Salesforce's AI vision to life, combining generalist intelligence with specialist agents to deliver real governed outcomes inside MuleSoft. And now, let's see how this vision translates into action through a simple bookstore API use case, where Falcon AI turns a single architectural prompt into 3 fully governed MuleSoft APIs. Now, let's see how Falcon AI's automation works in real example, the simple bookstore API use case. We're using MuleSoft API-led connectivity model, which includes 2 system APIs, one for inventory to manage stock levels, and one for payments to handle transactions, and one process API, the bookstore API, which orchestrates both to complete an order. The entire flow begins with an architect who defines the design blueprints and creates the prompts that drive Falcon AI. Each step in this process, from design to implementation, is prompt-driven, with 0 manual code effort. Falcon AI's intelligent agents handle everything automatically. We start with the RAML design phase. The architect uses a prompt to instruct Falcon AI to create 3 RAML specifications, one for each API. These RAMLs define resources, methods, examples, and security traits. Remember, this is just a prompt. The architect is not designing it, he's just issuing a prompt. Once generated, Falcon AI automatically runs checks and balances, validating naming conventions, governance rules, and security configurations. After approval, the same prompt-driven workflow instructs Falcon AI to publish these APIs to Anypoint Exchange, creating discoverable design assets that serve as the single source of truth. Next, the architect issues prompts for implementation, and Falcon AI's agents take over the development lifecycle. The development agent generates complete MuleSoft implementation for all 3 APIs, not just scaffolds, but full code with flows, connectors, data wave transformations. Governance and security standards are applied automatically during generation process. Folder structure, logging, error handling, and policy enforcement are taken care of. The code is also automatically checked into the code repositories such as GitHub, Bitbucket, etc. And the APIs are also promoted to the Anypoint Exchange so that you can then discover these APIs and use them in the implementation process. And the best part is Falcon AI generates bookstore process API with orchestration of inventory and payment system APIs automatically, wiring them together to handle stock checks, payment authorizations, and order confirmation without any manual intervention. So, from the architect's prompts alone, with no manual development, Falcon AI delivers 3 fully configured production-ready APIs, fully implemented, that are built, secured. So let's see how this works in a live demo. Let's try to generate code using Falcon AI now. I've just accessed the Falcon Suite login page, and I'm using Cloud Hub option to log in. And this lets me log in using the Cloud Hub credentials using single sign-on. So when I click on sign in, after a few moments, it should take me to the login page of Falcon Suite. And this is where I can see the Falcon AI landing page. I can see various options. We are not going to go into all of this in the interest of time. So I'll just use Falcon AI for now. And in Falcon AI, I want to use something called generate code. So if I go and click Falcon AI again, click on generate code, I can see that I have various options here. Generate Mule application, it just generates the Mule Mule code. So it's not related to any API as such, but it's purely a Mule code based on a prompt. The generate API specification is more of creating RAML specs. Implement API specification is based on the RAML spec generated in the previous step. It can use those RAML details to generate implementation. Falcon Eye and Falcon Scan Insights is to reverse engineer your APIs and generate documentation out of it. So we're going to go through each of these steps in detail in the next few minutes. So I also have created various prompts. So I have two system APIs and one process API that we described in the previous sections. So I'm first going to implement the inventory system API. So this is a prompt for me. So I'm gonna copy this prompt, and if I go back here, I want to create the generate API specification. Go to the next, give some name. So let's say inventory sys API, for example, and I can select the destination here. I can select any point design center where I want this to directly go and sit there, or I can select GitHub Bitbucket, or I can download it from the local repository as well. The RAML specification type, you can select either OAS or RAML types, and click on next. Organization, these are the anypoint platform orgs. And Falcon Scan comes up with its own default org as well. So I'm going to select shipment for now, and I'll copy paste this prompt here. And once I submit, I'm not going to do that now because it'll take a few minutes to generate. Because I've already generated this, I'm going to take you to the generated piece of code. So the inventory sys API, this is the one we generated. So if I go, you can look at the prompt here. That's the user prompt I'd given. And if I go and view the application, I can now see that it is created in the design center. So let me first go and look at the execution log. So it started off at 8:05 and finished at 8:51. So it took 46 minutes. From the steps, you can see that once the process is started, it has prepared the environment for the AI agent to pick up and start code generation, and it has downloaded a specific template, which is org specific template that we provided to the AI, and based on the template it created the project. And once the code is generated with AI, it used Falcon Scan to verify whether the code generated is compliant with your organization standards. This is an important step because this is where you are combining governance and the code generation. Without Falcon scanning your code, you will not know whether the AI, the LLM that generated the code, is doing the right thing or not. Now, other important part that happens behind the scenes using Falcon AI agents is that if the code generated is not compatible, Falcon AI automatically makes the corrections, makes adjustments. We've got a feature called autofix. So it automatically goes and fixes the code
before everything is done. So by the time you get to this stage, process completed stage, you have the code fully baked and the code published into the relevant repository, and you can straight away go and access the code without you having to rework, make the code compliant, make the code error free, etc. It's all done for you. Now if I go back here and click on Design Center, this straight away takes me to the Design Center where the API has been created and updated. So let's look at what it has done. So you can see a nice folder structure here. You see definitions, examples, libraries, RAM, security, types, etc. Again, this is based on the project template we've uploaded. This structure is usually not created by default by LLMs. You have to explicitly give instructions. Let's see what it has generated here, right? So one of the standard things we do always is to create the health endpoint. This is for the API monitoring tools to ping and check the status of your APIs. So if you look at let's say inventory sys API, let's look at some of the rambles here. Right, so you can see that there is a books endpoint and there is a stocks endpoint. So it's all created here, and you can see that you don't have to now go and make any changes. It's given some example rambles as well. So the ramble is ready for you. It's ready to be consumed. So I'm not going to go into more details of this because it's already been committed to Anypoint Designer. The next step is for us to go and commit this. So once you publish it, it'll go and sit in Anypoint Exchange. Again, I've done this, so I'm not going to publish it again. When I come back here, the next step for us is to implement this API. Once the API ramble spec is generated and the API has been published into Anypoint Exchange, the next step is to go and let me go back to Falcon AI. Next step is to create the API implementation. So now I use implement API specification option. Go to the next stage and give inventory sys API implementation, and the API to implement. Now the API will be visible from here. Inventory sys API, this is the one we published earlier, and I can select the destination again. The workspace is automatically preloaded for me, and the organization I'll select shipment. Dependent APIs, I'm not gonna use this option for now, but this will be interesting to see when we define the process API. And the prompt to create that, again, I have created the prompts. Again, the prompt is fairly straightforward. It's implement the get books, get stock, patch it, and create unit test cases, etc., etc. So all we need to do is copy paste the prompt here, and that's it. When you submit, it will start generating the code. So if I go back here, I've already done that. So you have inventory sys API implementation here, which is this one. If I go and look at it and look at the execution log, you can see that it has taken 9:01 to 9:29, which is 28 minutes. And you can also see that it has directly written it to Bitbucket. So if I click on Bitbucket URL, so the interesting part that you can see here is that we've integrated Falcon Scan with Bitbucket. So you're not waiting for the code to be scanned elsewhere, but the code results, scan results, can be seen directly from the Bitbucket interface. Now you can see that the Falcon Scan has scanned and it has the quality checks have been passed. So I have downloaded this into Anypoint Studio. I want to show that to you here. So let me close all of this. So you can see that inventory system API implementation is here. So I can see that, there is this nice segregation of the methods implemented, and each of the method is referring to particular subflow, flow reference, and the implementation here talks about how these flow refs are implemented. So I can see that I have all these things shown here. So all the methods are implemented. You can see there is a nice business logic created here, checking the books, checking for the stock availability. All this business logic has been built in. It has also created properties for various environments, and it has also created unit test cases, and it's all done out of the box just with the help of a prompt. Now, the other thing that you can see here, I have introduced this just for showing you that the scanning is happening in real time. So I've created a HTTP listener as opposed to HTTPS. So let me go back here. So if I go to global.xml and go to common.xml, go to configuration, I've created HTTP protocol as opposed to HTTPS. So if I change it to HTTPS now, it automatically scans the code, and that error is gone. So just wanted to show you that the scan is happening in the Anypoint Studio with the help of Falcon Scan plugin. Even though earlier generated code had complete 0 errors, I introduced this error just for demonstrating it to you. So that in case something escapes and your code is still containing maybe 1 or 2 errors, Falcon Scan adds that extra layer of checks and balances to tell you whether the generated code has any incompatibilities, etc. So now we've created the system API, inventory system API. Let's go back and start creating the payment system API in the similar fashion. So let me go back here. So I have the payment system API prompt here, and again I'll copy paste that, go back to the Falcon AI and create generate code, generate API specification, go, and it's the same routine, payment system API, something like this. RAML, organization, shipment, give the prompt and click on submit, and that will take you to the generation screen, which I've done it here. So the payment system API, book payment system API, if I go here, you can see that it has taken around 19 minutes. It started at 8 and completed at 8:19. Used all the standard checks and balances. The Falcon Scan is run, auto fix is applied, all the issues have been rectified, and before the process is completed, the published code is available from the Anypoint Design Center. So if I click on API Designer here, it'll take me to the API. Let's give a few moments. There you go. So the payment services API, you can see that it's got the health check, the charges and charges by charge ID resources, and again it has maintained the structure here, examples, traits and types, and it's again standard generation process. Nothing spectacular here, but it's all fully baked. That's the point I was trying to make. Now this system API is generated. I had already published it, so the next step is to go and create the implementation for it. So if I go to Falcon AI again, generate code, and this time we use the implement API specification. Go here, give the name So let's say it's payment system API implementation. The API to implement is payment system API, which is this one. Workspace is this. Next, organization shipment. Dependent APIs, there are no dependent APIs. The prompt here is this. So I want to show you something a little different here. So I'm introducing business logic, and the business logic is to generate a UID, a charge ID, UUID, unique identifier, and if the amount ends with 0.13, I want to return 402 decline. Otherwise, I want to return 201 status authorized. So now, once I give this and say generate the prompt, use that prompt here. Let's go back here. Yeah. So if I give this and click on submit, it would have taken me to the generated page, which is the payment system API implementation, which is this. So you can see that the execution has taken around 33 minutes, 12:08 to 12:41, 33 minutes. And it has checked the code into Bitbucket. So I'm going to go into Bitbucket now. And again, it shows us whether there are any issues. Falcon scans this and reports any issues. So the quality gate is successfully passed, and I have downloaded this again into Anypoint Studio. So let me take you to this part now, and let's close all the files. So what I wanted to show you here is, if I go to the implementation part, you can see here, check whether the payment should be declined. And you can see that there are two branches. One branch is to raise error, and the second branch is to process it. So if I go into the code, I'll show you how this logic has been incorporated there. So if I come here, you can see that there is a first step of generating UUID, which is here. And then if I go to the choice, check if payment should be declined, and return 402 payment. See, it has generated a nice documentation as well. And raise error type payment, app payment decline. And you can see here, if otherwise, you are creating the charge object, which is exactly what we wanted. So, so if I go back to message flow here, so the business logic here that we asked it to generate has been nicely generated. The other things, the standard unit test cases have been generated, and the folder structures have been maintained, and the properties have been created, placeholders have been created. So, again, this is an implementation that you can straight away lift and shift. Maybe you may want to tweak the data mappings, or add your own specific exception handling mechanisms. But most of the code, 90% of the code, is readily baked for you. Now we've completed the system APIs for both inventory and payment. Let's look at the process API for the bookstore. So if I go back here, I have the process API. So again, I'll have to generate one YAML spec for process API, and then implementation based on the YAML spec. So I've got both of them created here. So in the interest of time, I'm not going to take you to the entire process, but what I wanted to show you here is 2 points. Let's go back to Falcon AI. So if I go here, I've created the RAML spec here. So again, so this is where sometimes the LLMs take longer time. Usually it is anywhere between 20 and 30 minutes, but even though the process API RAML is a fairly straightforward one, simple one, it has taken around 1 hour 40 minutes. So it occasionally happens, maybe because the LLMs are overloaded. So now again, the process has been completed, the API has been checked into the design center, and I've published that later. So let's go and check that in the design center before looking at the implementation part. Right. So again, it has created all these APIs, the methods, and it has created nice documentation as well, because we asked it to create documentation in the prompt explicitly. And now the folder structure is here, so I've published it. So let's go back to the generate code part now. So if I go here, go to Falcon AI. So I've implemented the process API, book process API implementation here, and the prompt for that is this book process API implementation. I want to draw your attention to this part now. Right, so there is an orchestration step. So it's not just plain vanilla system API implementation, but the process API is now calling both system APIs, inventory and payment system API, orchestrating the responses, and then returning certain codes in reply. So if I use this and say go back to code with AI, generate code, and what I will have to do is implement API specification, go to the next step. I'll give bookstore process API implementation, something like this. Select API to implement. So I'll select the bookstore process API, which I had already created. And then go to the next step. Organization is shipment. Dependent APIs is where it gets interesting, right? So I want to create two dependent APIs here. One is inventory system API, and I also want to add the payment system API. Right, these two will be my dependent APIs, and this is going to be my prompt. So I'm asking it to orchestrate between these two system APIs and giving the reference of the system APIs here. And when I click on submit, it goes and creates this nice implementation for me. So I've already done that, which is bookstore process API implementation. So you can see the prompt here. And if I go click on this, and it has taken around 27 minutes. So you can see that roughly it's taking anywhere between 20 and 30 minutes. So the code has been generated, nicely checked into Bitbucket. So once I go to Bitbucket, I can also see whether there are any issues that Falcons can identify and reports. Now I've created one issue here. So sometimes an issue may creep in. Despite all the best efforts, sometimes one or two issues may creep in. That's where the additional layer of assurance in the form of Falcon Scan will come into picture. So in this case, it has created one small issue in terms of, I think, object store. Let me go and check that. It's bookstore process API implementation. So if I go back here, Mule projects, bookstore process API implementation, which is this. If I go and look at the issues, so I can see that object store payload message should not be stored in object store. So this issue escaped the previous governance layer, and hence Falcon Scan has identified and still showed it here. So I wanted to retain this for showcasing it to you, that sometimes it is possible that one or two issues may escape, but Falcon Scan and Falcon Suite will ensure that you will still have the visibility into those issues. Now the process API has been created and the implementation has been generated. If I go here and look at the process API implementation, and that's the implementation part, I can see that the place order flow, it has nicely used both the system API. It says that check inventory flow, which is where inventory system API is going to be used, and prepare payment request and process payment. This is where your payment system API is going to be used. So you can see that the respective system APIs have been orchestrated, and fairly you can see based on the code that it is production ready code, and all you need to do is go and verify whether data mappings are correct, exception handling is correct. You still need an architect to verify whether everything is going fine or not, but the architect will have the tools necessary for identifying any incompatibilities and vulnerabilities. So that's in a nutshell I wanted to show you on how system APIs and process APIs can be created. Just to recap, all we've done is created 6 prompts, right? These prompts are for system API and its implementations, and the process API and its implementation. And what it has done is created these APIs, RAML specs, and uploaded this into Design Center to Bitbucket, and it's done all these things without you having to write a single piece of code. Now the last bit I want to show you is about the insights. So again, if I go back to the Falcon AI and look at the generate code part, and if I select Falcon Scan Insights here and go and select the applications that I want to scan. So let's say I want to use Bookstore Process API implementation, and go and click next. I can give a prompt and ask it to generate only high-level design, maybe use case diagrams, maybe sequence diagrams. I can do give any details that I want, but I've kept it blank just to show you the level of details it generates even without you giving any prompt. So this is the code generated. So if I come here, you can see that it's got a fairly detailed documentation. So let's go through each section one at a time. So the project overview talks about the Bookstore API implementation. It talks about process layer, RESTful APIs, and order management, etc. The key features, it talks about inventory management, payment processing, error handling, API documentation, the summary of the entire process API. And that's a project structure. And the key components used here, again, keep in mind that it's all done automatically. You're not writing any single line of documentation here. You got API kit router, HTTP listener, API console, and the flow mapping. Business logic, it talks about various main flows and subflows, etc. So far it's only describing what is being implemented. Error handling, see, it's created its own codes, standard naming conventions. The dependencies, the Maven dependencies here, and how to set up this API, and how to run this API, usage examples, etc. So the important bit here is this part, right? So the architectural details, you can see that it's identified that it's an API-led connectivity pattern, and it has identified that this is a process API layer, and it sits here, and it is connecting to two system APIs, and the placeholder is created for the experience API, even though we don't have any experience API at the moment, but it has nicely put this into respective slots based on the API-led connectivity patterns. And it also talks about the order processing flow. It's a pseudo code where it talks about receiving order, parsing order for each inventory item, checking the inventory, processing the payment, etc., etc. So rest of the things, again, troubleshooting and support and maintenance. These are all some things we've added. But the point is, you can generate this documentation based on your own prompt, and it can also have a nice graphical interfaces as well. You can create, for example, if you want to report the number of issues found in a tabular format or graphical format, you can still do that in a just using a prompt. So this is the overall demo I wanted to give you. So there are few other things I wanted to cover in terms of best practices, in terms of where the LLMs can be made more effective, etc. So we are going to cover that in next few minutes. Here is what we learned during this entire process. The top 5 best practices based on our experience is that we need to start with a clear intent. So we need to define the goal, scope, and the outcome before we prompt LLM. So we need to have very clear instructions and very precise prompts in order to get reliable results. The second best practice is to treat prompts as design assets. So we need to think them as reusable templates that can contain our standards, policies, and organizational specs. And we can potentially have a layered prompts wherein you create base prompts and then you extend them to create specific prompts, etc. But maintaining a prompt library will be helpful. Third, always having the humans in the loop. So even though AI can do most of the things automatically, at every stage, having an architect approve or refine the outcome of a certain AI prompt or the outcome of AI prompt will be crucial, and that avoids any inadvertent errors creeping into your production code. And the fourth best practice is to build the governance and security at the time of generating the code itself, or not as an afterthought. So this means that you can plug in your organization rules, the data handling policies, the validation layers during the code generation itself. And finally, learning from the process and adopting continuously will be very helpful. So when we initially started off with LLMs, we realized that certain LLMs are good for generic questions, and certain LLMs are good for code generation. And over the last 6 to 7 months, we've seen that there is a substantial improvement in the quality of the outcome the LLMs generate. So playing around with LLMs, looking at the time it takes, the cost for generating the code, and constantly keeping a tab on the historical data and how things are progressing will help us make the most of the LLMs. So with those best practices, right, it's great that we have best practices, but how do you effectively implement them? Implementing this will require enterprise-grade platforms such as Falcon Suite, and this one brings in governance, security, and control directly into your AI code generation process. You don't have to reinvent the wheel; it's already built in for you. Falcon Suite ensures that every line of code that AI generates adheres to your organization standards, and the governance security are applied to the generated code. And if required, Falcon Suite will fix the code for you based on your organization standards and policies, and get you a fully baked, production ready code available. So, how do we get Falcon Suite to achieve some of these best practices. So let's look at the Falcon Suite's products in brief. So Falcon Suite consists of 4 key products. The first one is called Falcon Scan. Falcon Scan provides you with 230 plus built-in rules, and it is a static code scanning engine that combines the real-time scanning capability and can integrate with your Anypoint Studio. It can integrate with your code repositories such as Bitbucket, or it can also be integrated through your CI/CD pipelines. Falcon Eye is a runtime, a DAST tool, which is a dynamic application security testing. It helps monitor and scan your assets in the runtime. So if you've created APIs and applications and deployed them onto Anypoint platform already, and you want to have a visibility into the quality of the assets running into your platform, then Falcon Eye will be quite useful. It dynamically goes and scans all the assets and presents you with very useful reports and dashboards, so that you can get health status of your platform straight away from those reports. Falcon Pulse is the API monitoring and performance tracking engine. It tracks your API health, uptime, and availability. It generates alerts, and it creates runbooks for your quick troubleshooting, etc. And finally, Falcon Lens is the one that can deliver very deep analysis and insights into your assets. It can maintain a complete list of inventory, detect vulnerabilities, highlight deprecated components, and provide in-depth code inspection and reporting. So this is again done very transparently. You don't have to write any code for this. It goes and inspects your application code and comes up with hundreds of metrics that you can track and take a look at. So in short, the combination of these 4 products and Falcon AI can provide you with very powerful set of tools, not only to generate your code automatically, but also provide you with a built-in governance so that the the whole compliance with the best practices and organization standards is adhered at the very beginning, not as an afterthought. To logically conclude, let me also give you a very quick overview of Falcon Suite. So we'll start off with the Anypoint Studio, where the Falcon Suite Falcon Scan plugin has been installed. So the way we do that is to go to the preferences, and we give the service URL here, this security token, developer token, and this is where the quality profiles can be can be allocated for each project. There is a separate quality profile for scanning APIs, Mule. We also support Kubernetes scanning. And there are some statistics about the number of projects scanned and number of projects allowed based on the license, etc. So this profile can be changed based on the project or at each individual developer level. So we've already seen how the real-time scanning works, so I'm not going to go through those details again. So once the code has been properly analyzed and fixed, the next step is for the CI/CD plugin to take action. So it promotes the deployment, it promotes the application, packages it, and deploys it. Before deployment, it checks something called quality gate. So let me show you what quality gate is. So if I go here, go to quality control first. So inside quality control, I have something called quality gates, and there are some default gates. So let me inspect the default Mule quality gate. So what this does is it allocates certain number of certain count for each type of issues, and if the number of issues encountered during the scanning is within this range, then the deployment will go through, otherwise not. So in this example, we do not want to have any critical blocker or major issues, but we are okay to have minor and info level issues. So the second part is the quality profiles. So quality profile is similar to a snapshot of rules, subset of rules. So you can create any number of quality profiles, and within the quality profiles you can see the number of rules. So for example, in this case we have almost 230 rules in the default quality profile, and each of this rule can be activated or deactivated. You can delete the rule if you don't want, or activate or deactivate. And one more interesting feature is to add custom rules. So you can go to quality rules, which gives you an entire list of rules, and then create add rule. And this gives you a Groovy based very simple language on how you can navigate through the components and find out which tag you want to select and check. And then once it is done, you can also test it locally and then deploy it. And this can also be done from Anypoint Studio using the custom rules editor. And it is access control as well. So if you want to give this privilege only to certain users, you can do that. So that's Falcon Scan. Let me take you through Falcon Eye as well. So Falcon Eye gives you a complete overview of your runtime, Anypoint platform, the APIs, the API instances, and Mule projects. So what you're seeing here is a summarized version of all Mule projects across all of your organizations. And similarly, these are all the APIs that are deployed onto each of the organizations. So you can see inventory, shipment. So there are 2 orgs, and all the APIs have been summarized here. And there is also a way we can scan the API instances. So the advantage of scanning API instances is that you're not only scanning the code, but you're also able to scan the policies. So if you've deployed an API and that API does not have necessary policies, the Falcon Eye built-in rules will go scan your APIs and flag any security violations. If any policies are not, security policies are not correctly mapped, then this will prompt you to go and take action. So basically Falcon Eye gives you a complete control over monitoring your Anypoint platform. The quality checks on the deployed artifacts, not the development artifacts, but the ones that are deployed. So this is quite useful when somebody has already done the development and the and the applications and APIs are running, they are live now, but somebody else is taking over and they want to come and get a measure of the health status of your platform. Falcon Eye will be quite useful in that sense. And finally, I want to just show you Falcon Lens. Falcon Lens is a metric, metric monitoring tool, which will automatically go and scan all of your assets and find out the metrics. Those metrics can be, the history listeners and requesters and data weave components or any custom libraries. So it gives you a nice breakdown based on each org. You can then go and navigate through each of the org and see how many metrics are there for each org. The second important feature of Falcon Lens is the deprecations. MuleSoft have their own deprecated components, and if you end up using those and you're not keeping tab on the deprecation schedule, it can create security issues for you in the future. So we automatically monitor and make have a database of MuleSoft built-in components that have either declared deprecations or the future planned deprecations. So whenever you use Falcon Lens, we automatically take care of that. You can also create your own custom deprecations, wherein, especially if you have APIs and you want to deprecate some of the versions of the APIs, you can do that using this. And the third important feature is the vulnerability checks. So we use the Google's open source vulnerability library, which has a dynamic list of 1,000+ known vulnerabilities, and we use this to kind of keep track of the status of your deployed applications. And because this is evolving over a period of time, you can you can have the scans scheduled maybe one time or frequently, maybe once in a month or once in a quarter, just to make sure that your applications are not introducing any security vulnerabilities. And that's in a nutshell. I don't want to take too much time in going into Falcon Suite details, but I hope this gives you an overview of how Falcon Suite can create this governance layer that can assist the AI-driven development process. Without governance, AI is not going to be as effective as it should. So the whole Falcon Suite idea is to not replace Falcon AI, but it's complementing Falcon AI in introducing the governance and security layers in the code generation process. So to quickly summarize, what we've just seen, our simple bookstore use case demonstrated how Falcon AI automates the entire MuleSoft lifecycle. The architect starts by defining the design blueprint and YAML specifications. That's the only manual step, and it takes about 8 hours. This step is common for both manual and AI-driven development. After that, Falcon AI takes full control. Using architect's prompt, it automates the development, the testing, and the governance of each of the API, all in about 30 minutes. In this example, we built 3 APIs, 2 system APIs, one for inventory, another for payments, and a one process API, which is called Bookstore API, that orchestrates the entire order flow. Normally, this would take around 6 days per API, including coding, reviews, testing, and deployment. With Falcon AI, the same outcome, fully production-ready, governed, and exchange-published APIs was achieved in under half an hour each. That's a reduction of more than 80% of total delivery time, without compromising on governance, security, or quality. Across all 3 APIs, what would have taken 18 days manually was delivered in just about 3 hours using Falcon AI. This clearly shows how Falcon AI shifts the API delivery from being resource-heavy and time-consuming to being prompt-driven and enterprise-ready. We have seen how Falcon AI can completely transform the way APIs are designed, built, and delivered, fully governed and secure. If you'd like to explore how this can work for your organization, we'd love to walk you through a personalized 45-minute online demo. Simply scan the QR code or visit integralzone.com/bookonlinedemo to schedule a session. At Integral Zone, we are proud to be trusted by global brands such as AstraZeneca, Atlassian, Reckitt, and Shell, and we'd be delighted to help you on your AI-driven MuleSoft transformation journey. With that, we'll now spend the last few minutes answering your questions. Please feel free to post your questions in the chat section on LinkedIn, and we'll be happy to take them one by one. Thank you for joining today, and we look forward to connecting with you soon.